Hi guys, I'm going to go through some molarity problems with you, and then in this video also, I will go through some dilution problems with you. You'll have a chance to do it on your own, and then you can watch to see how I did it. So let's get started. First off, this is coming from our assignment that I gave you in class today, so if you look at number 3, you can follow along, and if not, then you have some practice problems right here. So number 3 is, what is the molarity of a solution that contains 0.00372 moles of hydrochloric acid and 2.39 times 10 to the negative 2 liters of solution? First of all, I feel like I have a lot of students that get kind of like wigged out a little bit by this number right here. And so you know that 10 to the negative 2 is simply moving your decimal places 2 places to your left. So this is the same number, although you could just punch in 2.39 times 10 to the negative 2. That's fine. So we're going to use our molarity equation, which is molarity equals moles over liters. And we have to make sure everything's in liters, and it is in this one. And we're already in moles. So we're just going to calculate, and we're going to plug and chug into our equation. And we're going to put that over, and I went ahead and just changed it to 0.0239. Again, you can punch that number into your calculator as well, as long as you keep it in parentheses. So the molarity here, if you just calculate and divide, then you're going to get 0.16 molar solution. So that's definitely a small concentrated solution. However, a lot of times, especially with acids or ionic compounds, you don't need a super high concentration. Let's take a look at the next one. Number 5, again, this comes from your assignment for number 5, or you can just go along with this problem. A beaker contains 214.2 grams of osmium fluoride and 0.0673 liters of solution. So we have to do a little math prior to our molarity equation because we are working in grams and not moles. So we need to convert to moles to start with because our molarity equation requires moles. So we're going to just convert here, just like we do our normal mole conversions. And so we find the molar mass of osmium fluoride. So we have 3 fluorines, 1 osmium. And I calculated it out to be 247 grams of osmium fluoride. And that's for every 1 mole of osmium fluoride. So if I go through and I basically divide, because I take 214.2 times 1 divided by 247, I'm going to get 0.87 moles. Now we are not done with this problem yet because my unit here is moles. So I need to plug into my molarity equation because the problem asks for molarity. So I'm going to put in my 0.87 moles. And according to my problem, I have 0.0673 liters of solution. And so I calculate there just by dividing, and I'm going to get 12.9 molar solution. Okay, let's take a look at the next problem. This is number 8 according to your sheet. And again, we start in grams, and we have a couple conversions to make because we have to go grams to moles, and then we have to go milliliters to liters because ultimately we need to be able to solve our molarity equation, which again, our molarity equation is, sorry about that, is molarity equals moles over liters. So let's go ahead and convert 14.92 grams of magnesium oxide, MgO, and we're going to find the molar mass of that, which calculated is about 40.3 grams of MgO, magnesium oxide, for every 1 mole of magnesium oxide. So this time we're essentially going to divide. So we take 14.92 divided by 40.3, and we get 0.37 moles of magnesium oxide. Now we have to change our 365 or 3.65 milliliters into liters. So we're going to move our decimal or divide by 1,000 because milli is 1/1000th. If we move our decimal 3 places, we're going to get 0.00365. So we come down here for our molarity equation. We have 0.37 moles of magnesium oxide divided by 0.00365 liters. And when we calculate this out, we're going to get a very large molarity, which is rare. This might be like industrial strength molarity of something or concentration. So we get 101.4. The next problem is number 10. And number 10 is if you evaporated 250 milliliters of 3.5 molar solution of iron 2 nitrite. So we got to do a few things here. Iron 2 nitrite is Fe and it's NO2, and that 2 comes down because iron has a +2 charge. So we have our molarity, it's 3.5 molar solution. We're going to change 250 milliliters to 0.25 liters, solve for our moles. So we take 3.5 times 0.25 and we get 0.875 moles. Now we've got 0.875 moles of NO2 of iron 2 nitrite, and we're going to convert that, and we're going to get 148 grams is our molarity for that. So we're going to multiply that 0.875 times 148 grams, and we're going to get 129.5 grams of iron 2 nitrite. So this is the molarity problems, and the next video will be some dilution problems. All right, you guys can do this.